Okay, 17. Now, this is actually quite a trivial question, but they make it look really hard, I suppose. So let's have a look. So what we're saying is that there's a square sum thingy, which you could read, and it's called awkward if and only if has a remainder of 3 when divided by 4. Okay, that's an interesting definition. So a theorem due to Fermat states that positive integer is a square sum if and only if each of its awkward prime factors occurs in even power in its prime factorization. Okay, I never knew that. Great to know. Okay, so and then they give you examples. Well, which one of the following statements is not true? Okay. Now, technically, there's a really obvious counterexample which makes this thing. If you look at C, like it's really trivial actually. Like if you look at C, well, okay, let's use the example. Like why not? 23 squared, fine. Why not? Well, then if you use the example, then let's set n to be 5 times 23 and then m to be 23. Well, then this thing doesn't work, right? Because I know if it's to an odd power, this is to the power 1, right? If it's odd power, then this thing explodes. This thing doesn't work, all right? So the answer is C, literally. Like, I'm not sure why this question is here. I mean, you could sort of see how the other ones are true. Now, A is trivial, right? A is trivial. You just write it as something plus 0 squared. Okay, B is correct because I know that I need it to be an even power, right? And if I multiply them, the powers add up. And even power plus even power still gives me the even power that I need. Okay, so that means that B is okay, right? Now, if n is not a square sum, then kn is a square sum for the sum of number k, which is the product of awkward primes. Okay, now this is interesting actually. It's actually quite a hard thing to prove. If n is not a square sum, i.e. it is some sort of 5 times 23, let's say, then kn is a square sum for some number k, which is the product of awkward primes. Well, is that true? Well, it has to be true because you could just fit in. Like for example, here I could choose k to be 23. Just make it right. Make it such that it becomes a power of what is it? Just a power. Make it even power. I mean, or just make it right. You could even choose k equals to 23 squared for no matter what's n. No matter what's n. No matter what n I choose, I multiply k equals to 23 squared. I think that would probably work as well, right? And it's a legit product of awkward primes. And I know that 23 squared, that is it's an even power, right? Okay, I suppose unless the n has 23 itself, okay? Okay, unless the n has 23 itself, then choose some other prime and then square it and then multiply it, right? This is quite a trivial question, I suppose. Okay, so the answer is C.